Okay, let's talk about matrix operations. So we're getting into chapter 6. This is kind of a lead in for matrices, maybe just to review some things if you talked about them last year. I really don't know if you did, but to kind of review some things about them, and then we can extend on that. So this is technically 06, section 0 for matrix operations. Okay, let's get to it. The first thing is just kind of talking about what a matrix is. So it's a rectangular array of variables or constants that are in horizontal rows and vertical columns. Okay, horizontal rows, vertical columns, usually they're enclosed in brackets, okay, like the ones you see below. We name them by an uppercase letter. So uppercase, capital letter, name it, and then we talk about an element as each value in the matrix is considered an element, okay? When we talk dimensions, if we have m rows and n columns, this would be a m by n matrix. Okay, so we go rows times columns. So these here down below, this would be a 3 by 4 matrix here because we've got 3 rows, 4 columns. So it'd be a 3 by 4 matrix. And then we talk about when we think about elements here, the element -1 is in row 2, column 1. That's its place, and we depict that by a sub 21. Same thing over here. This element -8 is listed in row 3, column 2. So we would say a 3, 2, row 3, column 2. Okay, just some kind of ways to place certain things as we go through it. All right, certain matrices have special names. For example, a matrix that only has one row is called row matrix. And then we have one with just a column is a column matrix. So those are shown right here. One row, one column. A matrix has the same number of rows and columns as a square matrix. So you can see that same rows, 2 rows, 2 columns in that one. And one that has all zeros is called a zero matrix. So you can see that one there. So just some kind of special ones. All right. 2 matrices are considered equal matrices if and only if each element of one matrix is equal to the corresponding element in the other matrix. So below here you see A and B are equal matrices because 2 and 2 are in the same element spot. Same with 4, same with -1, and same with 3. So that makes them equal matrices. So that's some general matrix knowledge. Now let's talk about matrix operations. So we can only add and subtract them if they can only be added or subtracted if they have the same number of rows and columns. So you can't add something that doesn't have the same number of rows and columns. So it's got to be the same matrix size. So to add and subtract them, we just simply add or subtract the corresponding elements. And that's that. So let's take a look at these examples here. So let's find each of the following. You've got matrices A, B, and C. Let's find A plus B. So to do that, we're going to basically take this A matrix and add it to the B. Because we can do this because they're the same. They're both 2 by 2, so 8 plus 12. So essentially what I'm doing here, I'm just going to make the big matrix and say it's going to be 8 plus 12. Then we're going to have 3 plus a -7. Just be careful with your negatives here. -5 plus 6 and 14 plus a -23. Okay, and put my bracket there. It's just simply adding here and here. Each element add it together and you've got it. Okay, so that's going to be, when we add those up, 8 plus 12 is 20. 3 plus a -7 is -4. Then you've got 6 and -5 is 1, and then 14 and -23 is -9. So simple as that. That's your final answer for them. Now, looking at number 2, B minus C. So if we're looking at number 2 here, let's take a look. Well, this is a 2 by 2 matrix, but this is only a 2 rows, 2 by 1. So we can't do that. Can't add or subtract. Because remember, they don't have the same number of rows, columns. So in that case, we can't subtract them. So no way we can do that. Okay, so let's go on to the back now, or the next page. So multiplication, we can multiply any matrix by a constant, and we call that constant a scalar. Okay, so we're going to basically scale multiplication. And we do this by multiplying each individual element by the value of the scalar. So you just take that scalar, it's on the outside here, and multiply it by every number inside. Okay, so very simple here. This new matrix C is just going to be 4 times all these numbers here and here. So 4 times 3 is 12, 4 times 6, 24. Then we have -4 and 16, okay? And in the second row, we'd have 28, 32, 4 times 8 is 32, -8, and then 12. Okay, so really simple multiplying. How about number 4 here? Should be pretty simple as well. -3 by all of those numbers. So we'd have -3, -15, 0 and 6, and then 18 and -12. And that would be my multiplication. Okay. All right. Continuing on, some properties of different matrices. So any matrices, if you have A, B, and C, let's say random 3 matrices, and then you have this matrix sum and product are defined by any scalar K, right? So you're multiplying by K. These all exist, and these are the same things that exist with real numbers, right? Commutative is just you could switch the order around. It's the same thing. Okay. Associative means if you have parentheses, I can kind of move the parentheses here to here, and it should be the same thing with addition. Distributive property is the same thing like we do in regular numbers. It's just you're going to kind of take every scalar, every member of the matrices, and become, distribute that by going, K times A, K times B, right? The same thing if you have on the right side, it's going to be the same thing, K times A, K times B. Okay? So no big deal there. All right. All right, so now let's kind of work with that down here at the bottom. So let's find 4P plus Q. So this is, it looks like a left scalar distributive property here. So I know I'm going to kind of have to take the scalar times the A and scalar times the B. In this case, it's going to be 4 times the P plus 4 times the Q. So when I do these matrices here, I'm just going to kind of write this one out as in terms of a very large matrix. So basically 4 times 3, but then it's going to be plus the 4 times 3 and plus the 4 times the -4. We're going to kind of keep doing that. So 4 times 3 and then 4 times -4. The next term. So then it's going to be 4, and you don't have to write this out every time. I'm just kind of doing it to show. So 4 times 8 plus 4 times 5. Okay. And then the third term would be 4 times -2 plus 4 times 7. Okay, and I can kind of close that matrix off. And then the bottom ones, 4 times -5 plus 4 times 3, 4 times 5 plus 4 times -10. And finally, 4 times -4 plus 4 times -6. Okay, so you don't have to write that all out. If you can do that in your head, it's no problem. So it's no big deal. But this is then going to become, when we do the math, 12, and then plus a -16 is a -4. The second term, 32 plus 20 is going to be 52. The third term, -8 plus 28 is going to be 20. And then on the bottom, you're going to have -20 plus 12 is -8. 20, that's a -10 here, right? Yeah. 20 minus 40 is going to be -20. And then -16 plus -24 is -40. So that would be that matrix C there, okay, using distributive property. So all those properties hold, and we can keep doing that. All right, the last thing today is talking about if we have a situation where we want to solve like equations, okay? So we can solve equations with matrices, just like solving equations for real numbers. We use a big capital X to represent the matrix solution, okay? So we're given two matrices, A and B here, and we're trying to solve 4x minus b equals a or x. So that's kind of what we're trying to look at here is we're saying, all right, we want to have this equation and we're going to solve for x. So what would we do to solve for x if it was a regular equation? So I would simply, it's a two-step equation, I would just add b to this side. So really I'm going to have 4x equals a plus b. So that's really the first step here is I'm going to kind of take 4x equals a plus b. So I'm just going to kind of add these up, a and b here, and get those. So -9 plus 5 is -4. 15 and -7 is 8. And then 4 and 8 is 12. Okay. At the bottom, 2 and 14 make 16. -10 and 10 make 0. And then -5, -3 make -8. So I added those up. That's just my a plus b. Okay. Then what would I do to solve, right? I would keep going. I would divide by 4 here. So really x is going to be a plus b divided by 4. Okay. Which is the same as saying, 1/4 a plus b. So instead of dividing by 4 here, I'm just going to multiply by 1/4. It's the same action. So I'm going to take this 1/4 and a times b is what I have here, right? I've got my a plus b is what I have here. So a plus b is this new matrix that I already created. And now I'm just going to divide it by 4 or multiply by 1/4. So my new matrix then comes out to be -4 divided by 4 is -1. Then I'll have 8 divided by 4 is 2, or 12 times 1/4 is 3. And then at the bottom, 16 times 1/4 is 4. 1/4 times 0 is 0. And then -8 times 1/4 is -2. So there you go, with my final answer being right here. Okay, so that's it. That's kind of a basic introduction to matrices, and we're going to obviously continue along with these a little bit more as we go. But this is kind of the introductory step. So talk to you next time.